Hello everyone. Welcome to the solution of LeetCode problem 1514 named path with maximum probability. In this problem, you are given an undirected weighted graph of n nodes represented by an edge list where edge of I is A and B. That means there is an undirected edge connecting from the node A to node B with the probability of success of traversing that edge, which is given at success probability array. Now, given two nodes, start and end, we have to find the path with the maximum probability of success to go from start to end and return its success probability. Now, if there is no path from start to end, we have to return 0. So let's consider the first example. Here, there is a connection between 0 to 1, 0 to 2, and 1 to 2. And the success ratio is 0.5, 0.5, 0.2. So here, the starting node is 0 and the ending node is 2. So if we go from 0 to 2 by using this direct path from 0 to 2, the success will be 0.2. And if we go to from 0 by using this path 0 to 1 and 1 to 2, the success will be 0.5 into 0.5, which is 0.25. So among both of them, 0.25 is the maximum. So we have to get the path from 0 to 1 and 1 to 2. So 0.25 is the answer. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken the same example. Now, the question is, how can you solve this problem? First of all, this is a pure graph problem, and if any of the graphs we are given the weight of the edges, most of the cases, those kind of problem can be solved using the Dijkstra algorithm. So to implement the Dijkstra, we always use the min heap, but here we have to use the max heap because we have to get the path with the maximum probability. That's why we have to use the max heap. Now here, the starting position is 0 and the ending position is 2. Now, initially, we are at this position 0. So from 0, let's say our success probability is 1 and our current node is 0. So we will insert it into the max heap. Now from 0, we can go to the node 1 and node 2. So if we go to the node 2, its success ratio will be 0.2 and the node will be 2. And if we go to the node 1, its success ratio will be 0.5 and 1. Now after that, we have to remove this from the max heap. So in our max heap, we have found 2 of the nodes. Now we have to initialize 0 with 1 and 1 with 0.5 and 2 with 0.2. Now, what is the top element of our max heap? This is, and the node is 1. So we are at this node 1. So from 1, we can go to 0 and we can go to 2. So if we go to 2, the probability will be 0.5 multiplied by 0.5, which is 0.25. Now, we have to assign 0.25 into the 2 and we have to remove it. After that, we have to assign 0.25 with the value of 2 here. So this is how the basically Dijkstra will work. And after completing the iteration, we will find that from 0 to 2, we can reach with the probability of 0.25. And this is how the Dijkstra basically works. I hope you understood the algorithm. Now let's move on to the code. Here we are given this function max probability, which has integer n and a vector of edges and success probability, and the starting node and the ending node. Now we are taking the adjacency list, which is a vector of pairs, and we are building the adjacency list here. After that, we are declaring a priority queue with the pair of double and int, and initially our distance will be initialized with integer minimum. And initially our distance of a starting node will be 1, and we are inserting 1 and starting node into the priority queue. Now, while the queue is not empty, we have to store the front element of the queue into a variable current and remove it. Now, for each of the children will be iterative first and the weight will be iterative second. Now, if the distance of current element into weight is greater than distance of children, then distance of children will be equal to distance of current element into weight. And we have to insert the pair of distance of children with children. Finally, after completing the iteration, if the distance of ending node is equal to integer minimum, we have to return 0. Otherwise, we have to return distance of end node. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.